Hi everyone. For my project, I chose to do some analysis on the subreddit Wall Street Bets. Commonly abbreviated as WSB, it's a controversial forum for discussing stock trading. It's notable for its colorful and obscene jargon, as well as its aggressive and often nonsensical trading advice. It gained notoriety in early 2021 for playing a major role in the GameStop short squeeze and its resulting market volatility. My goal for this project was to scrape 6 months worth of posts and train some classifiers to detect toxic comments and hate speech and to perform sentiment and personality analysis. I'm going to go quickly through the slides, so pause the video to take a deeper look at any of the graphs being presented. I used the Python library praw to scrape the Reddit posts. I ran into an issue early on where it's not straightforward to query for historical data, but you can query for posts by their unique ID. So I grabbed a dataset from Kaggle that contained posts from February 7th through July 15th, and I used the post IDs from that dataset to query for the full post from Reddit, and then persisted that data in MongoDB. This is a list of the fields that got persisted into MongoDB. This graph shows the number of monthly posts color-coded by flared topics. You can see the huge bump around the time of the GameStop short squeeze. Instead of a word cloud, I chose to show common parallel word occurrences, starting with the word stock. Then I did topic modeling using Gensim, which uses an algorithm called LDA, a Bayesian model for discovering topics. I initially modeled with k=5 and noticed that there are 4 well-defined clusters in the data. I reran LDA with k=4. The 4 clusters are 1. GameStop with lots of profanity, 2. Stock fundamentals, 3. Trading fundamentals, and 4. Buying and selling GameStop. I started off with attempting to train a model to detect toxic comments. My training data was Wikipedia comments that were labeled by human readers. As you can see, the data is very imbalanced. I started with an LSTM, a type of recurrent neural network capable of learning order dependence in sequence prediction problems. It is effective in memorizing important information. I used Keras on top of TensorFlow. The network starts with a pre-processing layer to vectorize the text input, then the LSTM, followed by a hidden layer, and then the output layer. I used cross entropy for the loss function and also ATOM, which is an adaptive learning rate optimization to stochastic gradient descent. I performed my model training using Kaggle notebooks, which provide 30 hours a week of free GPU training, which significantly decreased my training time for this step. As you can see, the model performance is not super great. High precision and low recall for true values. Also, the model fails to ever classify a threat, though this category does have very low support. It's pretty decent at detecting obscenities, though I think this is because that category is very keyword based. Next, I tried to remedy the imbalance problem, starting with adding class weighting. I used sklearn's compute class weight function to compute the weights, which are then provided to the cross entropy loss function. As you can see, positive recall improves in every category, but positive precision is now terrible, meaning a lot more false positives. Though depending on the goal of this model, that might be an acceptable trade-off. Also, the model is now classifying threats. Next, I try out some sampling and boosting strategies. These don't readily apply to a multi-class classifier, so I would need to train a separate model for each class. For the sake of time, I only tested these approaches on the hate category. I used the IMB Learn or Imbalanced Learn library for a lot of these strategies, which is a cool toolbox for imbalanced data sets. I ran into some technical problems trying to get IMB Learn to play nicely with TensorFlow, so I switched to naive Bayes from sklearn for a few of these, which may have tainted some of my results. Model 1 was naive Bayes with smote. Model 2 was naive Bayes with borderline smote, which is a variation of smote that oversamples misclassified instances of the minority class. Model 3 was XGBoost with borderline smote and random undersampling. Model 4 was XGBoost with borderline smote and Tomek links undersampling. Tomek links removes ambiguous examples of the majority class by finding examples that are closest to the minority class. Model 5 was XGBoost with borderline smote and class weighting. Overall, the model performances were mediocre, barely better than random, sometimes worse. Next, I tried an ensemble approach, consisting of my original LSTM model and the LSTM with class weights. I compared weighted voting versus simple averaging, with simple averaging performing better overall. Next, I applied the simple averaging ensemble to my WSB data. It detected at least one of the toxic categories in about 30% of all the posts. Posts containing the flare tag discussions were the most toxic overall, with about 55% of the posts being flagged. Here are some examples of text that my model categorized for each class. Next, I tried to detect instances of hate speech. For this task, I used a pre-trained BERT model from Hugging Face. BERT is a transformer-based technique for NLP pre-training developed by Google. Transformers are neural networks that use the technique attention to differentially weigh the significance of each part of the input data. Attention is a technique for spending more time on smaller, important parts of input data. My pre-trained BERT model was trained using data from Gab and Twitter with human rationales added. Human rationales are basically manually written explanations on why text belongs to a particular class. There has been some research showing that adding human rationales to training data can improve model accuracy. This diagram shows that my model classifies 6% of posts as offensive and a small fraction as actual hate speech. Here I filter the posts down to just those classified as angry, which is a minor spoiler because I haven't discussed sentiment analysis yet. Offensive matches increased to 34%, showing a correlation between anger and offensive text. Here are some examples of text that my model categorized for each class. Next, I performed sentiment analysis and emotion tagging. For this task, I used pre-trained Roberta models from Hugging Face. Roberta is an improved version of BERT developed by Facebook. As you can see in the chart on the right, there are quite a few BERT-based sequence learning approaches. Roberta removes a step in BERT known as next sentence prediction and then adds dynamic masking. Masking basically means that random words in an input sentence are hidden from the model during training. Masking helps to reduce overfitting. In BERT, masking is performed once during pre-processing, resulting in a single static mask. In dynamic masking, for every epoch of training, the random masks are reapplied, which allows the model to see different versions of the same sentence. My pre-trained Roberta models were trained on a dataset of 58 million tweets, fine-tuned for sentiment and emotion recognition. This graph depicts sentiment versus post count over time. This graph depicts emotion versus post count over time. Here are some examples of text that my model categorized for each emotion. Here we can see correlation between sentiment and emotion. Negative text contains more anger and sadness than positive, while positive text contains more joy and optimism than negative. Here we can see correlation between the emotions anger and joy and toxic comments. Toxic comments have more anger and less joy than non-toxic comments. Here we can see correlation between sentiment and toxic comments. Toxic comments are more often categorized as negative than non-toxic comments. Next, I tried to classify Myers-Briggs personality types of posts. Pause here to look at this brief overview of MBTI. For simplicity, I will equate personality types to the Star Wars characters in this chart. My training data was about 8,000 labeled examples from Personality Cafe. The dataset consists of a person's MBTI and 50 sentences that they posted to the forum. As you can see, the data is very imbalanced, with a large bias toward intuitives. The distribution per category as seen in the right diagram is a little better. So instead of training one model to predict 1 out of 16 types, I did 4 models, each predicting 1 out of 2 opposing values. As part of pre-processing, I converted the training data into TF-IDF vectors, then trained 4 XGBoost classifiers. I attempted to use a pre-trained BERT transformer as part of the tokenization step, but this did not improve accuracy. I probably would have had better results if I could have found a BERT or Roberta model pre-trained on MBTI data. My model accuracy is decent in detecting introvert versus extrovert and intuition versus sensing, but it's mediocre for the other 2 classes. My results show that about 47% of posts are from Luke Skywalkers, while 31% are from Yodas. Interestingly though, Yodas get more upvotes and more than 3 times the comment replies than Luke Skywalkers. I promise we're almost done. So was anything I did original? Probably. There's been a lot of interest in Wall Street bets recently, but so far I haven't seen anyone apply toxicity, sentiment, and personality analysis to it. What did I use from data mining 2? I used LSTM, ensemble models, voting strategies, multi-class classifiers, XGBoost, smoked, undersampling, oversampling, class weighting. What are my lessons learned? Well, I wish I went with a smaller scope project, maybe just 1 model, then I would have had more time to analyze results. Also, I spent too much time retraining toxic comment models in hopes of improving performance. Here's a list of my references. Thanks so much for watching my video.